In this video we will see how to get weights for multi-criteria decision analysis using analytical hierarchy process. There may be 5 steps. One is you have to define your objective. Suppose in this case I am getting a suitability for a sorghum crop in some region, and then second one is identify factors based on expert. So based on your expert's opinion, you have to identify some factors with which you are going to get a suitable area for your objective. So here in this example I have taken rainfall, soil texture, soil available water capacity, then organic carbon, depth and slope. So 6 parameters we have identified. You can have more. Then third step is make pairwise comparisons with expert opinion. So for this is the pairwise matrix. So here what we do, suppose we are having these 6 criteria. So for every pair we have to compare, and every pair means rainfall to rainfall, rainfall to texture, then rainfall to AWC, rainfall to OC, then rainfall to depth and rainfall to slope. Similarly texture to rainfall, texture to texture, texture to AWC, texture to OC, texture to depth and texture to slope. So similarly you have to create a matrix of this comparison. So this comparison will be based on this table of Sati. So see, rainfall and rainfall, since we are comparing the same, so it will be 1 by default. Similarly texture to texture will be 1, so I am writing 1 here in the diagonal. And then now suppose rainfall and texture, so you have to compare only one pair independent of others. So suppose rainfall and texture you are comparing for sorghum, you feel that rainfall is very much important. So this importance is like equal importance is 1, then moderate importance 3, strong importance 5, very strong importance 7 and extremely importance as 9. Now in between you can use 2, 4, 6, 8 also. So based on your expert's opinion you have to define this comparison, this rating. So suppose between rainfall and texture you find that rainfall is more important than texture, and how much important, suppose you find it 5, so 5 you can give here. Similarly if you find that between rainfall and AWC, again rainfall is important but not much, if your expert suggests it's a moderately important, so you have to write 3 here. And remember we are comparing first pair, in the pair first is rainfall, then AWC, then we are using 3. If suppose your expert suggests that AWC is more important, then in that case it will be a reciprocal of that. So suppose AWC is more important, then it will be reciprocal of this, so it will be 1 divided by 3. So this is one example. So I will come to original. So rainfall is more important here, so it will be 3. Then between rainfall and organic carbon, suppose it is 7, means rainfall is very strong important than organic carbon. Then suppose then there is depth. So it will depend on your objective. So since you are defining suitability for sorghum, then depth will not that much important and rainfall is more important. In that case you can have 5 or 6 in anything. Suppose it's a crop is different which need higher depth, then you have to the depth may be more important. So in that case you have to write just reciprocal of this. So 1:5, 1 divided by 5. So I am coming back to the original for this objective. Then slope also, between rainfall and slope you find rainfall more important, you can have like 7 or 8, anything. Then first we have to fill this upper diagonal, then we will come to this also. So like between texture and AWC, suppose you find texture as more important but not much, suppose 3 you are giving. Similarly texture and organic carbon, texture is more important than organic carbon, suppose, so then you have to give 5. And for depth you can also have 1 here, like if you find that depth and texture are more equally important, then you can have 1 or 2, means based on your expert's opinion. Then texture and slope you want, suppose if you want 5. Similarly AWC and OC, AWC is more important, suppose 3. Then between depth also 5, 2, and then AWC and slope again if you want 5. Organic carbon and depth, suppose it's a depth is more important, suppose, then you have to write it's equal to 1 by whatever, means this based on this table, suppose 1 by 3. And then between organic carbon and slope, suppose organic carbon is more important, so that would be like this. And between depth and slope, if you experts suggest that depth is more important, suppose 3. Now as I have told you that where rainfall and texture is 5, if texture is more important, then it will be, see, suppose in texture is less important, rainfall is more important here, so it will be inverse. So you have to inverse all these here. So here it will be is equal to 1 by this. Similarly is equal to 1 by this. Here also is equal to 1 by this and 1 by this, 1 by this. So you have to fill all this in the same manner. 1 by this. Like this. So I am filling it. So this is our final pairwise matrix. Now we will be calculating the weights. So for that, first we have to create a sum of all these. So you can use auto sum. So this is sum of all these. Now you have to make a second table like this, same, but here every cell you have to divide by the sum. So we'll write like is equal to this divided by this, and you can write here like a dollar sign, so that it will be like this, and you can drag it here. So this is this divided by this, this is this divided by this. So after doing this, you have to get a again one more column, you have to add average. So you have to average it. So directly you can write average of all these. You can drag it here, and if you are summing it up, it should be 1. Means sum of these all, this column should be 1. Now this is your average. So these averages are weights for each parameter. But before using this average, you have to first check it for biasness or consistency. Then only we can use it. So for that, you have to calculate a term called lambda. So this is nothing but a matrix multiplication. So you have to write is equal to formula mm, means ULT. So in this you have to give, for suppose we are calculating it for rainfall. So you have to write, you have to give this array, then comma, and then average array, and then you have to divide it by the average of rainfall. So this is your lambda for rainfall. Then again we'll go MULT means matrix multiplication of this array means for texture, then this array, close the bracket, and divided by the weightage for texture. So similar way you have to do for all. For AWC, for OC, and for depth, for slope. So this is your lambda. Now we have to get the maximum of this. That is called lambda max. So you can directly get it. The formula of maximum of all these. So maximum is 0.694. Then you have to calculate one more index, that is consistency index. So I am writing CI here. It is nothing but this maximum of the lambda, so is equal to this maximum minus n. N means number of parameters. So you are having 1, 2, 3, 4, 5, 6. So you have to write 6 and divided by n minus 1. So 5 divided by 5. So this is your consistency index. And now this is also given by Sati, this table. So here for 6 the consistency index is 1.24, means this is a random consistency index. So means random consistency index I am writing here. So this random consistency index for 6 number of parameter is 1.24. Now you have to calculate the consistency ratio. So this consistency ratio is this divided by this. It is 0.15. Now ideally it should be, if there is no biasness or your matrix is consistent, then ideally it should be 0. But up to 0.1 it is considered as consistent. So now it is showing that your this matrix is not consistent. So you have to see, this is texture is strongly less importance and AWC is moderately low importance. But here you are giving that texture is moderately important than AWC. So here you can see one bias is there. So you can write here like is equal to opposite 1 by 3. Similarly identify the inconsistency here, and accordingly you have to see that this should be less than 0.1. So accordingly I have corrected this, and remember this is just an example. You have to sit with your experts and carefully define this matrix. So now you see this is less than 0.1. So finally these weights are consistent. So now you can use these weights in your multi-criteria decision analysis model. So in next video I will show how to use this in apply these weights in rasters of this to get a suitability map. Thank you for watching.